review from yesterday, 13.1. We're going to talk about special right triangles. So if I have a triangle that I know that it's a right triangle and I know one angle is 45 degrees, then we know that the other angle has to be 45 degrees. So what can you tell me about the length of the two sides? The two legs?
The same.
They're the same. So now on your little sheet it says 1. I'm going to have you actually put an A there, or A times 1. You want to do it that way. So if the length of one leg is A, what's the length of the other leg?
Oh, I got you.
Also A.
I see.
Okay? So now if we figure the length of the hypotenuse, then it would be A squared plus A squared equals C squared. So 2A squared equals C squared. Takes the square root of both sides. So the square root of A squared is A. Square root of 2 is root 2. So C is A root 2. Okay, and that's true. So that relationship between the three sides is true no matter how big or small the triangle is. So if I know the length of one side of a 45, 45, 90 triangle, I can find the length of the other two sides. So our other special right triangle, and on your little sheet you're given, and it's 30 degrees up here. So if that angle is 30 degrees, it's a right triangle. What's the remaining angle? 60 degrees. Okay, now, just to help you remember the proportions on a 30, 60, 90 triangle, I'm going to have you very likely sketch a reflection of the triangle that's there. So that's like the same one was laid on the side. If that was the case, this would be 60 degrees. This would be 30 degrees. So the triangle we just created, what kind of triangle would it be? Equilateral, right? All three angles are 60 degrees. All three sides are the same length. So, and yours says 2 here. I'm going to tell you to put 2A. So the length of that side, which is the hypotenuse of our original triangle, is 2A. And the whole length of this other side on the bottom down here would be 2A. So what would be the length of this short leg here? Just A.
Oh.
It'd be half of 2A, which is A. Okay, which is why I chose 2A to start with. We don't have to have a fraction. Okay. Now let's figure out the missing leg. So I would say A squared plus B, if we call this one B, B squared equals 2A in parentheses squared. So A squared plus B squared equals 4A squared. So B squared equals 3A squared. I subtract A squared from both sides. So B would be, the square root of A squared is A. Square root of 3 is root 3. So the length of this side would be A root 3. Again, that relationship is the same for all 30, 60, 90 triangles, and you're going to be using that in your assignment today. This little blue sheet is going to be your friend. Keep it where you can see it, where you can use it. Now, the second part of this sheet is we're going to look at the trig functions of those three angles. So let's start with 30 degrees. Now, you should know these exact values or be able to figure these exact values of all of these particular trig functions. These are things that show up lots of places. It can show up on the ACT test. It shows up, if you continue on into pre-calc next year, you will use it a lot there. If you go into trig stats next year, you will use it a lot there. This is good stuff to commit to memory. Lots of places it shows up. So, 30 degrees. If I am looking at the sine of 30 30 degrees. I know the sine is the opposite over the hypotenuse. So I come over here to the 30, 60, 90 triangle. Opposite the 30-degree angle is an A. The hypotenuse is 2A. So the sine is A over 2A, which simplifies to 1/2. Okay, so let's look at the cosine. What's that?
Every single time, 1/2.
Every single time. It doesn't matter where it is, the sine of 30
Or what
degrees.
numbers are in there.
No matter what's with the A, what the A's are, it's always 1/2. Okay, so same as for the cosine. Let's look at that one. I look at the side adjacent to the 30-degree angle. That's A root 3. And the hypotenuse is still 2A. So I have A root 3 over 2A. The A's cancel. And I get root 3 over 2. Okay, so then the tangent is opposite over hypotenuse. So let's see. 30 degrees. Opposite is A. Hypotenuse is A root 3.
Yeah, you got that.
Opposite over adjacent. Okay, you're right. Thought about it, right? Didn't write it through. There we go. So I've got A over A root 3. A's cancel, so I get 1 over root 3. Can't leave that root 3 in the denominator all by himself. So I multiply root 3 over root 3. And I get root 3 over 3 for the tangent of 30 degrees. Cosecant. Now let's take the easy way out on this. It is 1 over the sine, or the hypotenuse over the opposite side. So yeah, the reciprocal of 1 over 2 is 2 over 1, which is just 2. Secant, it's 1 over the cosine, so that's going to be the hypotenuse over the adjacent side. So that's going to be 2 over root 3. Got to rationalize the denominator again. So I get 2 root 3 over 3. And the cotangent, now I'm going to look back to where I started with the tangent. I have 1 over root 3. So when I take the reciprocal of 1 over root 3, I just get root 3 over 1, which is root 3. Okay? So no matter where you find a 30-degree angle, those values will always be the sine, cosine, tangent, secant, and cotangent. Okay, so let's look at 45 degrees. So let's see. Doesn't matter which 45-degree angle I choose. I'll choose this one down here. Okay, so that would make this side opposite. Well, the opposite is A. The adjacent is also A. The hypotenuse is going to be A root 2. So when I look at the sine opposite over hypotenuse, that's A over A root 2. Well, my A's cancel. That leaves me 1 over root 2. So multiply by root 2 over root 2. And I get root 2 over 2. Okay. Now let's look at the cosine. Adjacent over hypotenuse. Same thing, right? So it's going to be, we can go straight to this. Root 2, we already did the work for that. It's root 2 over 2. Okay, so let's look at the tangent. Opposite over adjacent. A over A. Gives me just 1. Anything divided by itself is 1. Okay, so now we get to do the cosecant. Hypotenuse over opposite. Well, A root 2 over A is going to be root 2. same for the cosecant. Since it's 1 over the cosine and the sine were the same, the cosecant is going to also be root 2. The cotangent is the reciprocal of the tangent. Well, the tangent was 1. The reciprocal of 1 is 1. So 45 is kind of an interesting one. Sine and cosine are the same. Tangent and cotangent are the same. Cosecant and secant are the same. Okay, last one. I'm going to have to move this up so you want to be looking at your little sheet when we look at the different parts. Now 60 degrees, now it's a little different than 30 degrees because, now I will look at the triangle for just a minute here. When we had 30 degrees, this A down here was the side opposite, right? Well, now it's 60 degrees. This is no longer opposite. This is now adjacent to the 60-degree angle. And when I look at the side over here, the A root 3 was adjacent to the 30-degree angle. It's now the opposite side from the 60-degree angle because it doesn't touch that angle. So, when we look at 60 degrees, opposite over hypotenuse is going to be A root 3 over 2A. A's cancel, so I get root 3 over 2. Interesting. Cosine of 30 degrees, sine of 60 degrees are the same thing. Is that a surprise? Think about the triangle. They're talking about the same sides, right? You know, yeah, put that away. Adjacent over hypotenuse for the cosine. Adjacent is now A. Hypotenuse is still 2A. These cancel and I get 1/2. Tangent is opposite over adjacent. Well, the opposite is now the A root 3. Adjacent is the A's cancel, so I have root 3. The cosecant is 1 over the sine. Well, that was root 3 over 2. But when we did that the last time, root 3 over 2 is 2 root 3 over 3. Same as the secant for 30 degrees. The secant is the reciprocal of the cosine, so 1 over 2 is reciprocal, is 2. The cotangent is the reciprocal of the tangent, so that's 1 over root 3, which is root 3 over 3. So when you compare the 30 degrees and the 60 degrees, what do you see? The tangent of the 30 degrees is the same as the cotangent of the 60 degrees. The cotangent of the 30 degrees is the same as the tangent of the 60 degrees. Same for sine and cosine, secant and cosecant. So they trade places. What we call 30 and 60 degrees are called complementary angles. You guys should know that from last year. Anytime you have complementary angles, that's going to be true of your complementary angles. Okay. There it is. So, one type of problem you're going to have today, that's not that one. There we go. That's what I'm looking for. Okay. Types of problems you're going to have today is if I have a triangle and I have it marked that the two legs are the same length and that the hypotenuse is 3 root 2. Have your little blue sheet handy. How am I going to find what x and y are?
3.
They're 3, and how did you decide that?
It's a 45.
It's 45, 45, 90, because these two sides are the same length.
A root 2, so 3 is A.
Okay. The hypotenuse is always A root 2. This is A. So I took A root 2, I divided by root 2, and I get a y is 3, so what's x?
3.
Also 3. Okay, everybody see that? Okay. then this other one, you're given, you have a triangle. The hypotenuse is length 8. This angle right here is 60 degrees. What's the other angle? 30 degrees. So now, is X or Y going to be the short leg? X is the short leg because it's opposite 30 degrees. So if you look at your little sheet, if the hypotenuse is 2A, then the short leg is A.
4.
So X is 4.
Y is 4 root 3.
The long leg is A root 3. So that's going to be 4 root 3. Easy enough? Okay. So let's just look at a couple more of those. So this one, you're given that this angle is 60 degrees. So that makes the side we're given the long leg. Our other angle is 30 degrees. So Y would have to be the short leg. So if the long leg is A root 3 and the short leg is A, what's the short leg going to be? Divide by root 3.
4.
And the edge is 4. My hypotenuse is 2A, so I take 2 times 4, and X equals 8. Now sometimes they are going to give you something where you don't have the nice root on the hypotenuse, just like it looks like on your picture. So what kind of a triangle is my next triangle? The x's are the same. So this is going to be a 45, 45, 90 triangle. So that says that if this is, the hypotenuse is A root 2, then the two legs are both A. Well, if I want to find out what the leg is, I take, say, A root 2 equals 8. Well, how do I find A? Divide by root 2. So A is 8 over root 2, but I can't leave it like that, right? Take it times root 2 over root 2. So I get 8 root 2 over 2, or 4 root 2. So both of these two sides are 4 root 2. Okay, so that's a good part of your assignment today, figuring out some of those. Now, the other part is based on a story problem like this one. Goes like this, and there's a lot of information here, so pay attention. An angle theta is in standard position. So the first question is, where's standard position? Standard position means that the origin is the vertex of your angle. So that's the first thing. Second thing, its terminal side passes through the point 4,3. Well, terminal side means where it ends. So we're going to plot the point 4,3. We're going to draw a line from our array from the origin through that point. That ray that we just drew is the terminal side of the angle. The angle is measured. You'll notice I put a little arrow on it. We'll talk more about that tomorrow. Because our angles are going to have direction. So theta is this angle right here. So now I want to evaluate all of the trig functions at that point. Kyle, open your eyes. So what I'm going to do is I'm going to create a right triangle. On that right triangle, what is the length of the side along the x-axis? X-axis. On the y it will be 3. Now, what's the length of the hypotenuse? Everybody should know this one quick. 5. 3, 4, 5 is a Pythagorean triple. If it isn't a nice Pythagorean triple, you say a squared plus b squared equals c squared, and you find the length of the hypotenuse. So let's figure our trig functions here. Sine is opposite over hypotenuse, so that's 3 over 5. Cosine, adjacent over hypotenuse, 4 over 5. Tangent, opposite over adjacent, 3 over 4. Okay, the next ones are all reciprocals. So cosecant is 5 over 3. Secant is 5 over 4. And cotangent is 4 over 3. Okay. Your first problem on your worksheet is exactly this problem with different numbers. Now before you quit, one more thing I want to tell you about. If I didn't have these numbers in here, this point could be any point x, y. If that was the case, this side where we put the 4 would be x. This side where we put the 3 would be y. And where we put the 5 would be r. You can use these numbers. Sine is y over r. Cosine is x over r. Tangent is y over x. Cosecant is r over y. And secant is r over x. Cotangent is x over y. These can be very helpful in solving those particular problems. You have an x, you have a y, you can figure out your r, you just plug them in. Okay, that's all of your notes for today.